We're going to go ahead and take a look at Lesson 3.1, Introduction to Cartesian Graphs in Coordinate Planes. And so let's go ahead and look at this first situation here where we look at plotting points. And so the instructions are here in your lesson book. Here is the first example that you can see here where it says plot. And plot means, again, to kind of indicate a location on what we call the Cartesian graphs or the coordinate axes or the X and Y axes. There's a lot of names you may hear for that. Rectangular coordinate system because of the shape. So there's a lot of terms that get used for that. And so you can see -3, -4 is in this location, over 2, up 3 is in this location. So your first task is to plot those points there. And so at this point too, I want to introduce an online website that you'll be allowed to use during the exam. It's called Desmos.com. This is what it's going to look like here. And so when you get to Desmos, you want to start graphing. And so there's going to be a lot of things we can do here on this website. And so one thing is we could plot points, and all you have to do is plug in numbers like this, -3, 4, and then the point will come up there. So it's a good way to just practice your plotting points. So that's one way to use Desmos. It will show you so you can get an idea, practice some different points in there. You'll get an idea of how plotting works. And so you can see if I put a 0, 3 and so forth, you can see it appears here. But so that's one website we'll be able to use because we're going to graph equations here, but when we get there in a few minutes. So I want to make sure you're aware of that. And so then looking at from the lesson book, you can see how you could plot these points, and Desmos does that. So let's go ahead and look at a little bit of this lesson here. It starts with a situation that we had done in lesson 2.6 here. And you can see here's the data from Washington, which was the population. And so just to remind you of some previous terms here, we had this absolute change between Washington and the population. So you can see the answer would be 800,000 here by looking at these two values here. And so what we're doing here is that we're trying to introduce graphing from the sense of we use it for a reason other than just plotting points. And so in this case, we have the year, we have this population, and we have this absolute change. And then compare it to this idea of relative change. What would the relative change be between those two years, 2010, 2000? You can see the answer would be here. And so you might need to go back and look at lesson 2.6 to remind you of the difference between relative change and absolute change as we look at that there. And so what happens here is we're going to kind of use this data, and why we make a graph is because many times that graph tells a story. And so in this case here, before this graph here is made, to make that graph, what we looked at here is I plotted the 2 points, as it says, plot the points here. So you can see I plotted that first value here, and then we had in 2010. And so you can see some pattern of growth you see some pattern of growth that exists between this 2000 2010. And so what we're looking at here, this question of how would it grow in the future? So the question was, or the challenge was, draw 5 different potential futures for Washington State. And so given this kind of pattern, we can go in almost any direction. And so using the information we have, we're going to analyze 2 possible situations that it could grow as. And so one way is through an absolute change, and just looking at how the population grows every 10 years by 800,000. If it continues in that pattern, we end up with this scenario here, where it grows up 800,000 every year. And so maybe that's how the population grows. If we look at how the population grows, and then we plot that, you can see this one is, you can see this pattern right here. If we draw the graph here, comparing that to if we did the same idea but with relative change, meaning that it's growing at 13.56% as opposed to 800,000 per 10 years. And so then you can see a different pattern emerges. So what we have, oh, here's the relative change. This is for relative change. Again, you may need to pause the video so you can look at these values here. But as you get these values here, we end up with two different stories being told. One is more of a line and one is more of a curve. Here's the ones in green here. And then these are the ones that were in red dots here, as you see kind of that growth. There's two different growth patterns, and so we study those two different types of patterns. One's a line, and one is what we call nonlinear, or something that's not a line. You see more of a curve. So you want to get those points in. You can take a look at the results we have based off of this set of values with a relative change, and this set of values with a constant change or absolute change. And you see the two different patterns. You have a line and then you have a curve here. And so that's what we're looking at as we think about how we want to analyze and what stories being told as we go through that. And then here are some answers to this question here, right? That one of them is a straight line and then the other one is not a straight line. And so what we end up saying for this one here, we're going to name those, but again, it's a nonlinear relationship, and we'll learn in the next video what do I mean by that versus it being in a straight line.